Alright, when we're multiplying fractions, what we're looking to find is a number in the numerator, that's on the top, and a number in the denominator, that's on the bottom, that are divisible by the same number. So in this example we have 4 and a 1 in the numerator, and we have 6 and a 10 in the denominator. Well, 4, 6, and 10 are all divisible by 2, so we're going to reduce the 4 and the 6 by dividing each of them by 2. Now 4 divided by 2 gives us 2, and 6 divided by 2 gives us 3. So now we have a 2 and a 1 in the numerator, and a 3 and a 10 in the denominator. Well, as it turns out, 10 and 2 are both divisible by 2 as well, so the 10 when we divide it by 2 gives us 5, and the 2 divided by 2 gives us 1, and for our answer we're left with 1 times 1, which is 1, and 3 times 5, which is 15. Now, hopefully this doesn't look too complicated, but let's see what would happen if we didn't cancel before multiplying. Now, canceling before multiplying is a very important skill. If we start with 4 over 6 times 1 over 10, that gives us 4 times 1, which gives us 4, and 6 times 10, which gives us 60. Now this fraction can be reduced. Both the 4 and the 60 are divisible by 2, so if we divide the 4 by 2, we're going to end up with 2, and if we divide the 60 by 2, we're going to end up with 30. But 30 and 2 are also divisible by 2, and if we divide the 2 by 2, we end up with 1, and the 30 divided by 2 gives us 15. So we've arrived at the same answer, but notice, in the calculations in the first row, we don't end up with very large numbers. In fact, the biggest number in the entire calculation is 15, whereas in the second row of calculations, the biggest number is 60. That's an awfully large number, and the numbers can get quite a bit larger than that. We want to reduce before we multiply as much as we possibly can. Now in this question, we have 5 over 8 times 1 over 4. 1 isn't going to help us at all because that can't be reduced any further, and so we're going to have to look at the 5. Now there's no number that divides evenly into 5 as well as 8, and there's no number that divides evenly into 5 and 4. So there's nothing that can be simplified here, so our answer is just going to be 5 times 1, which is 5, and 8 times 4, which is 32. Now when we look at this question, 4 over 9 times 6 over 7, hopefully you are starting to notice that some of the numbers are multiples of each other, like 6 and 9, for example, are both multiples of 3. So 6 divided by 3 gives us 2, and 9 divided by 3 gives us 3. It doesn't look like there's anything else that can reduce here, so we have 4 times 2, which gives us 8, and 3 times 7, which gives us 21. We can check on our counting grids, and sure enough, there's no row that has both the number 8 and 21 in it, so it can't be reduced any further. So again, we take a look at our numerators. We have a 1, which can't be simplified any further, and a 2. Neither 3 nor 5 are divisible by 2, so there's nothing to reduce, nothing to cancel, so we have 2 over 15. There's all sorts of stuff that can cancel here because we have a 4, we have a 6, and we have an 8. All of those are multiples of 2. They're all in the row of 2 on our counting grid. So the 4 is going to cancel with something. Now we can cancel the 4 with the 8, and we can cancel the 4 with the 6, but I'm going to choose the 4 and the 8. And if I do that, 4 divided by 4 gives us 1, and 8 divided by 4 gives us 2. So now our answer is going to be 5 times 1, which gives us 5, and 2 times 6, which gives us 12. But let's take a look what might have happened if we'd chosen to do something else. We have 5 over 8 times 4 over 6. Now once again, all of those numbers are divisible by 2, so let's choose to do something with the 6. 4 and 6 are both divisible by 2. 4 divided by 2 is 2, and 6 divided by 2 gives us 3. But notice now that we have a 2 in the numerator and an 8 in the denominator. Both of those are divisible by 2. 2 divided by 2 gives us 1, and 8 divided by 2 gives us 4. And that still gives us an answer of 5 over 12. Different path, same answer.